already. And really, we only have, we are halfway through our unit or through our year. Midterm grades go out next Wednesday. And that is our official halfway point. Remember, next Friday, you do not have a test, or you don't have school. You don't have a test because you don't have school. Your test is going to be next Thursday, but next Friday, you all get a day off and you guys get a break, whether you want to use that to get caught up on anything, or you just want to sleep in and say, heck with school. You get to do that next Friday. So please make sure you have your interactive notebooks out. We're going to go through and review the explain section, specifically slide number 15. And then we're going to look at taking the Molecules of Life mid-unit quiz. Please make sure that if you guys have any questions, throw them in the chat or stop me. Like, it's okay to use your microphone and say, hey, can you go back, or hey, can you review that again? I want to make sure that you guys kind of have this down. The slide 15 kind of connects everything we've done for this section. Next week, it will be into the last two sections of our notebook, and then you'll turn that one in. I'm going to give you guys until that following Sunday to make sure you have everything, but it would be a really good idea over the weekend to make sure that the engage section, the explore section, and the explain section, the first three, are taken care of before we move into next week. That's probably the biggest thing that's affecting some grades right now, is just not turning in work. So please make sure you're doing that. Questions so far?
So wait, how many days do we have to work on the notebook, the digital notebook? Because I have a few more things to do.
Yeah, so it's
do we just have today?
No, the digital notebook, it's not actually due until next Sunday. Yeah, okay. So you guys have time. It's just if you were keeping on a pace to make sure that you're not getting behind, that would be, hey, make sure over the weekend those first three sections are done. So then next week you only have the last three.
Okay.
Yep. Remember our goals, they were big, but it has a lot to do. If I had to kind of summarize this out for you, would be knowing those important elements, okay, in biology, knowing the monomers and polymers for each of our biomolecule groups, and then being able to describe metabolism and those two types of reactions that we looked at yesterday. And that's what we're going to review today before we take our quiz. Okay. So let me go ahead and I'm going to share my notebook again. Remember, you are free to, we're going to call it borrow my responses in my notebook, because I really want you guys, this is a skill we're going to be building even outside of digital learning. You guys are going to be doing this when we get back into the classroom as well. So I want to really make sure that you have really good examples of what I'm looking for in these sections and how to use them to, I like to say, think smarter, not harder. Okay. So let me go ahead and share that with you. So yesterday was all about looking at what we call metabolism. Okay, and a lot of you guys have probably heard that term, metabolism, or and people like to refer to it as, oh, your metabolism's really fast or it's really slow. What are they usually referring to when they say someone has a really fast metabolism? Or have you guys ever heard that expression?
I have. Isn't it like you can lose weight really quickly or gain weight or whatever?
Yeah, so a lot of people attach it to like weight loss or your size, and how fast you process food. Okay, now that's how we refer to it kind of in our day-to-day life, in that connection. So we're going to look at what does it really mean though when somebody has a fast metabolism or their metabolism slows down. What does that look like? Okay, so based off of the reading, okay, that first key point was kind of like, what is metabolism in the first place? Metabolism is a fancy word for all of the chemical reactions that are taking place inside your body every second of every day. Okay, so, and then from there, we're going to break those types of reactions down into two major types. Okay, so if somebody has a fast, quote, fast metabolism, that just means that their body is really efficient at doing these chemical reactions. When somebody has a slow metabolism, it means that their body is just not, it's kind of sluggish in getting this work done. Okay. Now, the two types we're going to be looking at are going to be what we call catabolism and anabolism. So catabolism are the types of reactions where we're going to break things down. Okay, so we need to break things down when we digest foods, when you eat. That's an example of what we call a catabolic reaction. So we're taking something that is large, for instance, like big macromolecules, and we're going to break them down into their parts. Okay, so think of it as going from like our polymers for each of those macromolecule groups to their monomers. And those monomers can actually be broken down even further into their atoms, the atoms that make up those monomers. Remember, carbons, hydrogens, oxygens, nitrogen, phosphorus, and sulfur, those like 4 to 6 that were super important, that's the ones we're talking about with the atoms over here. So when we have catabolic reactions, we're taking something big and we're making it smaller. But we can't just rely and stay here. There's the other side to this. There's the opposite side. And that is our anabolic reactions, or anabolism. So anabolism is all of the chemical reactions that are going to make bigger things. So we've broken something down. So think like you've eaten your meal, you've digested it, it's gotten to your stomach, the digestive enzymes, all that munch, breaks your food down. That's the catabolic side. Now your body has to do something with it. Say you've been exercising, or you have to repair some muscle, or really anything. Your body, when it goes to build those macromolecules or those polymers that they need, are going to be using an anabolic reaction. So we're going to go from atoms to monomers, or monomers into polymers. So we're building back up. Okay. So metabolism, if I had to summarize that whole thing together, would be metabolism is a collection of all of the chemical reactions that happen within the body. When our body breaks down the biomolecules in our food, catabolism, and rebuilds them into the products we need to function properly, anabolism, that's metabolism. Okay, so metabolism, think of it as like our big title, and everything falls under that. Now, using this information from yesterday and what we know about how monomers and polymers are related, I wanted you guys to give it a shot and make a flow chart. Now, if you've never made a flow chart, okay, I will share this one with you on Google Classroom, but I'm going to walk you kind of through what we're looking at here. So I have metabolism here in the center, and everything that circles around it is metabolism. Okay, as a part of that metabolic process. Now, think of it like a freeway or a road. You have 2 lanes, okay? One going in each direction. That's kind of how we have it set up for here. So on this side, when we're going to go down, so we're going south, this is going to refer to our breakdown. The biggest molecules that we're going to be working with right now are going to be the polymers. So underneath each polymer, I color coded and I said, okay, this is the polymer for carbohydrates, which is starch. The polymers for proteins, which are polypeptides. The polymers for fats are fats. And the polymers for nucleic acids are DNA. Okay, so these, and with any one of these, I could pick one of these categories and I would start here. Okay, now in a catabolic reaction, I'm going to go from my polymer to my monomer. And I have all of my monomers listed underneath of it. So the monomer, remember using orange for carbohydrates. So my monomer for carbohydrates, an example would be glucose. Proteins would be amino acids. Fats would be fatty acids. And your nucleic acids would be a nucleotide. But I can go even further. So I could break those monomers down into their individual atoms, which would be carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Now this spot right here, this rearrangement of atoms, and sorry that little guy keeps popping in and blocking us, but that's the foundation that connects everything, is the fact that all of our biomolecules are made up of the same types of atoms. This allows our body to really take any structure that you give it and get it down to that level and then flip around and go back the other way and build anything that it needs. So once I get down here to the basic atoms, so I'm sitting here with all of these like atoms, carbon atoms, hydrogen atoms, oxygen atoms, I can now, your body can flip around and it's going to start to build monomers, or those single molecules. Okay, so if your body needed to build some glucose, it can take those carbon, hydrogens, and oxygens that it pulled from whatever you put in, and then it's going to flip around and use that to build bigger polymers. Okay, so if you're reading this, you could go from starch to glucose, glucose to carbon, hydrogens, and oxygens, back to glucose, back to starch. So you could follow that route. However, let's say, for instance, when you're looking at, a lot of this has to do with people's diet, and that's why we kind of associate that word metabolism with our diet and how thin or fit or overweight or whatever, however people want to categorize it. But let's say you had somebody who's decided they do not want to eat carbohydrates. They're like, nope, they've heard carbs are bad. Nope, can't do it. Well, remember what carbs do for you. They are your primary source of energy. That's their go-to. Okay, that's what they want. That's what they function most effectively with. So if a person did that, they're like, nope, I'm just going to eat all protein, 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 meat, 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 meat. So what that process looks like in their body is they're going to start off with these polypeptides, they're proteins. Your body is then going to break down those proteins or polypeptides into amino acids. Now, if you remember back to our protein slide, proteins were made of carbons, hydrogens, and nitrogens, and oxygens. So I have those 4 building blocks. Now remember, carbs are only carbons, hydrogens, and oxygens. So you've still given your body, with eating just protein, everything that it needs to be able to turn around and say, okay, if you aren't going to give me carbs, I will just go ahead and I will make the glucose myself. So then your body goes, okie dokie, I'm going to take those carbons, hydrogens, and oxygen atoms, and I'm going to make a structure like a monomer similar to glucose. And then I'm going to use that and then I'm going to store it later as these bigger molecules. So you can really start with any color, and once you flip down here, any biomolecule, once you get to this base level, your body can then turn around and build whatever it needs to. Ricky, you heard that oxygen is bad for your body. Weird rumor. I wouldn't rely too much on that though. Okay. Questions about this little flow chart or how you could read it?
So mine looks a bit different.
And that's totally okay. This was just an example of one. If yours, like it shows you like a step-by-step process, then that is perfect.
Okay, because mine goes from the atoms down to the monomers down to the polymers, and then the catabolic switches from the polymers to the monomers, and then they go back.
Okay.
Leaving the atoms out.
Oh, gotcha. Okay. Yeah, the biggest thing to remember here is that like it's like this. If you were to draw a diagram and you kind of took this idea, so on the for catabolism, you went from a polymer to a monomer to an atom, that's totally fine. For anabolic, you go atoms to monomers to polymers, or just monomers to polymers. Remember, not always, depending on what you give it, will your body go all the way down to this level. You could just go from polymers to monomers, monomers to polymers, and that's okay. The big thing to remember here is that whenever you are taking something big and breaking it down into something smaller, that's a catabolic reaction. Anytime you're building something, so taking a small item and going bigger, that's an anabolic reaction. Okay. Good questions. Anybody else have anything they want to discuss? Or if I can even go back slides too, if you guys missed anything from slides 12 through 14. Okay. One thing to remember about this unit, and if we're looking kind of at this example right here and the connection between monomers and polymers, think of it like a puzzle in your body. So we are constantly trying to fit these pieces together, and sometimes we're going to have puzzles that are, we're going to take something and go smaller and then build back up. But all of these guys are connected. Your proteins are connected to your carbohydrates, which are connected to your lipids, which are connected to your nucleic acids. Everything in your body, all those big macromolecules, they are related. And the atoms, okay, the elements that make them up are their common denominator. That's the link that holds all of this together and allows us to make all of this really cool, diverse material in our world. Okay. All right. That's really the basis of our unit, guys. So if you're like, okay, this, I can see the picture, I can see it kind of come together, then you are in a really great place. These are the foundational like clues though. So next week we're going to get into how are you going to take this information and apply it to some scenarios. And this is the big fallback. Okay, polymers to monomers, monomers to atoms, atoms to monomers, monomers to polymers. Okay, so this is your fallback thing. So when we look at our lab next week and our elaborate activity, this is what I want you guys to fall back on. And if you would like me to, I can cut out, I can save this as an image and I'll load it up to Google Classroom so that you guys can have that. If this makes sense to you, then you can totally throw it into your notebook if you're like, oh, I really like that and that makes sense. Okay, so I will do that here in just a moment. All right. If you guys do not have any questions or you guys are not struggling in any way, okay, I'm going to pop back out of here and then I'm going to go ahead and I will open up your guys' quiz. It is a 15-point quiz. You guys will know what you got. There's no short answer questions in the quiz. It's all either true, false, matching, or multiple choice. The big things that you're going to be asked to do is link your monomers with your polymers for each of the groups. What are the big elements? Okay. Oh, Colin, I like that. Sorry to cut myself off there, but catabolic crush, anabolic architect, that's perfect. I'm going to steal that from you. I really like that one. So to kind of give some background, so catabolic reactions, they're going to crush things down. So when you crush something, you make it smaller. When you're an anabolic architect, architects build. So if that kind of makes sense to you, that's a really cool little way to remember it. I like that. Thank you for sharing. And then in your notebook or in your quiz, it's going to ask you, hey, what is an example, or is this picture diagram an example of a catabolic reaction or an anabolic reaction? Okay. Questions before I let you guys jump in and give it a shot? All righty. Okay, if you want to take a few seconds to review over, you can do that. I'm going to open it up, and so that way, for those of you who are ready to go, you guys can start. Please make sure you finish your quiz by the end of the class period, which is 12:50. So within the next hour, I want you guys to make sure that that is ready to go. If I do not have your material within or your quiz within the next hour, I'm going to be hunting you down. Okay, so it is due today during this class period, so please make sure you have that done. Okay, bye Xavier. I have not opened it, Colin, so nobody has access to the quiz yet. Sneaky like that. All right. It is officially, there you go, officially live. I've got you set up, Colin. You're good.
What's the assignment for AR time?
The assignment for AR time, that's a good question. I will go on and get that loaded up during this class period for you.
Can you go back to slide 15?
Yep, this is slide 15. Can you still see my screen?
Okay, thank you.
Mm-hmm.
So once we finish the quiz, is the class period over?
Yep, once you guys are done with the quiz, you are free from me for the weekend.
Okay, thank you.
You're welcome.